Hi guys. Good evening and well, first of all, thank you for coming. It's a great pleasure that we initiate this meetup. I decided to create this meetup because I wanted to learn more about data science, Python, and I was lucky enough to find other guys with the same initiative like Yashin and Vince. Hopefully we'll create a nice community around that will meet regularly and let's see where does it take us. Also would like to thank you, the guys from Fusion, and I want Adela or Lucas, they'll give a short presentation about Fusion. Okay?
Sure. Thank you so much. Hello everyone. Thank you for coming today. So who knows Fusion? Wow, pretty good. So I know, guys, they are the fellows. They are kind of part of the acceleration. It doesn't count. Okay, so I believe you having some of you already here, but I'm going just to tell you who we are. We call ourselves Global Catalyst for Corporate Innovation and Startup Acceleration. We actually focus, we are based in Switzerland, but we are global. We have startups and corporates from around the world. Our mission is actually supercharging innovation and innovators. So we started 3 years ago as so we started 3 years ago. I'm going to do like.
You need to go closer to
the thing. It's kind of. Okay, thank you. So we started 3 years ago as a fintech accelerator. So you can see it's fintech. So we leverage new technologies. We are currently specializing in blockchain. We have AI, cybersecurity, and big data. We have also PropTech, which is more specialized into IoT solutions. PropTech actually is real estate technology, and we are also focusing on a smart city and smart outdoors. And we have also LifeTech, which is digital health. And we of course have specifically in technologies like IoT, artificial intelligence, among others. We have a bunch of partners today from fintech, PropTech, and LifeTech, and we have a lot of resources partners, strategic partners, and others. We love new friends, so please go on Facebook, LinkedIn, Twitter, wherever, like us, love us, talk to us. If you want to know a little bit more about us, you can ask us. You can send us an email as well, so adela@fintechfusion.ch. You can look us around. And if you're in a startup or you are just willing to think about ways of doing your startup, or you are willing to collaborate with us on the technology side, please talk to us. Okay, so thank you so much for your time, and I wish you a very nice event. Thank you so much.
Thank you, Adela. I will describe a little bit the agenda for today. So we'll start with Nitin. I had the pleasure to meet a while ago in Zurich. He will give us a talk around data science from a business perspective. And then we'll get Yashin and Vince, and they will explain what we're going to do and what is also where this meetup is going to, in which direction we want it to go. But this is open to discussion. Like, if you guys have any idea, feel free to interrupt us, and we're here to discuss. So, well, I'll give the mic to Nitin.
Am I audible to everyone without mic? No?
Hey.
Yeah. I'm not used to it. So, before I start this, there is something, I heard the tech word several times already: AI, cybersecurity, and fintech. What I noticed, what is very common among all of them, is the analysis part. And we are here with the option to learn Python, or to maybe, and I'm guessing that most of you are interested, or almost all of you are interested in using Python to run some sort of analysis. And I put that under the domain of data science, and that's what I'm trying to introduce. I'm not trying to teach you any machine learning, any programming, but I'm trying to teach you what you should do when you approach a data science problem. Because this is something I find it missing from everyone I have spoken to so far about data science. You know, how you start a problem and how you end the problem. And the first question is that how many of you are doing actually data science or data analysis or some sort of data related work? So everyone, cool. So there is a slide which will come in some minutes. I would ask another question like that, and then I want to see how many hands rise at that point. So let's start. So hi, my name is Nitin Kumar, as you can see it here. I'm working with Propulsion Academy. What we do is that we are specialized in organizing bootcamp courses. Like the idea came from US that the market needs a lot of people who are technology savvy and are into technology, but the demand is very high, but the market is not supplying. So the Propulsion started last year with the goal that maybe we can supply such students or such people to the market by training from the market. So people who are ready to move from one field to another within a small, with a small investment of 3 months. So that was the main goal. Such idea exists in US. There are a bunch of data insights and New York data science retreat, and there is one in Berlin, there is one in London. So there are several of them. You can probably Google about them. Now, a bit of information about me. So I'm not from a tech background, but I'm doing tech. So I studied in India, the red color boxes, my graduation and master, they were both in the life science industry. The reason I studied life science was that because at that point, I really wanted to know how life works, how cell replicates, what different types of cells there are. Because for me, the goal was that if I can understand how life works, maybe I can translate that knowledge. Hello? Hello? So, that's good. So maybe I can translate that knowledge into some other industry, and that's why I studied microbiology. I had a minor in maths and stats in my graduation and in my master's both. And in my master's was the first time I actually had a laptop in my hand. My mom bought me one, and that was a time I liked statistics, so I wanted to use statistics to do something in the life science. And that's where I started programming in MATLAB, Shell, Perl, to process protein structures, and I got into, per se, what they call in the data science right now. Later on, I came to University of Zurich to do my PhD in data mining or biostatistics. My work basically there focused on collecting whatever study was published wherever to identify data related to mutations in cancer genomes, and then access the data, standardize it, normalize it, make it available to the research community in a standard format, because all of you, those who are working with data, might have noticed that there is no standard format. People do whatever they want. So that's what I did in my PhD, and simultaneously analyze that those data and collaborate with a lot of other people in analysis perspective. PhD disappointed that the output there was just the way they judged my output was using papers, which I got a lot of them. But that didn't lead me anywhere. I was thinking, hey, my work is not making any impact. The only impact that it's making is that I have a very good Google Scholar Citation Index. That's it, nothing else. So I gave it a push. I said, okay, I'm going to go for another postdoc. And I'm going to go for a postdoc. So I went for a postdoc at Kinderspital, or the Children's Hospital in Basel, with the hope that the work I'm going to do is going to have impact in clinics. Same output, papers, good impact papers, high impact papers, published everywhere, a lot of citations. Okay, so clinics is also not the way. I have to change it, I have to have some impact of what I do, or I should feel it. That was the time I switched to a small consulting company in Zurich as a data science consultant. There I worked as a consultant for airline industry, so Swiss Airlines, for SBB, and a lot of internal projects. What I did for airlines is that I developed a data duplication engine for them, which is deployed and still running as far as I know. So most of you might have flown with Swiss Airlines. Whenever you go and book your tickets, you give your entries, you tend to make mistakes. So my algorithm finds those mistakes and tries to find all the information about you in their system and bring it all together so they can track you better. Not a good thing, but it paid. So right now I'm working as a program manager at the Propulsion Academy. So I started there as a teaching assistant when David but then you can't see it. When David was a student, and later on I stayed back to develop the program a bit more. Do you guys see it or better? Good. So what I'm going to discuss is the why, what, who, and where in data science, and how. So the question is how you approach a problem in data science at the end, and then talk a bit about propulsion and what we are doing, and maybe someone is interested in coming for a data science program there. Now, first question is, why are we talking about this? We have all gathered with the idea, okay, there is data science, and I'm guessing that most of you are interested in getting some sort of job in some sector in data science. So this is an old study, but it talks about the number of graduates that are produced in US every year. So one can see that the life science is overly populated. In a year, they produce 183,000 life science graduates. And if you look at the number of jobs, it's only 12,000. Where do the rest of them go? Become cooks? Well, I really have no idea. Computer science has always been the main field and still is. So computational scientists get a job very quickly, immediately after their PhDs. And I really like the title, so many degrees, so little demand. So these people have to be absorbed somewhere, and that's where propulsion or our company comes into play. Now to follow up further on this was another study from 2015 done by IBM, looking for data science associated jobs. So the jobs which require some sort of analysis skills, and according to that study in 2015, we had 2.3 million jobs available in the Swiss market for analysis-related jobs. A 40% growth was projected, and what is very interesting here is that it takes on average 5 days more to fill data science jobs than any other industry. That already shows, hey, there are people in the market, so something is going on there. Now, it's again 15% projected growth, and for data science and engineers, it's specifically 40. Now, we know why. Okay, so data science is needed by the market, and that's why we are training people in data science. Now the question is that what is data science? So I took this definition from Wikipedia. It's apt, but not very apt. So we'll look into this. It's a data-driven science, an interdisciplinary field. So it's neither physics nor engineering nor statistics. It's a mix of all of them. Now, focus has to be given on the data-driven side of it. Whatever assumptions you make, whatever you think about doing with your work, you have to let the data talk. Always let the data talk. You have a question, ask the data. Don't ask your colleagues, don't ask people in the next office, ask the data, and data will answer because it is there. Now, one point which I really like here is that it employs techniques. It employs them. It's not mathematics. It uses the techniques from different fields to answer data-related questions. So you don't need to be a perfect mathematician, you don't need to be a perfect statistician. You need to know a bit of all of them to become a good data scientist. Now, what is a data scientist? So this is a definition which I really admire. A data scientist is a person who knows better statistics than a software engineer, and who knows better engineering than a statistician. To me, this makes sense, because that's at least how I came into the field. I knew better statistics than engineers and other way around. And obviously there has to be a way to become a data scientist. I'm sure most of you are taking courses on Coursera or Udemy, digging deep into machine learning, regression, artificial intelligence, all those techniques which everyone is talking about every day. But there is a proper roadmap which most of you might have seen somewhere, that hey, where do we start? I see that people come, when in the last program I had 9 students in my company, and all of them came with the goal that they will learn how to apply machine learning to the data. But what they were dragged to is to start with the fundamentals. Do you know what a matrix is? Do you know what an invert of a matrix is? This is what you need to know to start getting to data science. So you start somewhere with the beginnings of the very beginning of maths, which you might have seen in your school. Then you move on, and then you focus on the statistics part. This is where the data science originated, statistics. A lot of people are not even able to define p-value. They all talk about it, but not able to define it. What the variance of data is, it's very important to know. It's just, it's the spread. You have to think about distributions. So these are the topics which I find interesting and should be very, very important for data science field, but are not discussed at all. Now, on the side of statistics, you have the programming part. Again, programming is a tool to implement your ideas, nothing more. The computer will only do what you ask it to do. So if you can do it with your brain, you can write it on a piece of paper, you can make the computer do it. That's how I think data science is a challenge. Now, once you have learned the basics of math, some programming, and some statistics, then you move on to the complicated part of it, machine learning. You cannot jump to machine learning without knowing statistics. You have to know the statistics. Now, NLP comes later on because NLP just uses the tools and techniques from statistics and machine learning to answer questions related to text data. There are some side networks or side metros going around, like data munging. You should know how to perform cleaning on data, because if the data is messy, your results are going to be messy. Basically, garbage in, garbage out. There is something about data ingestion. You should know how to fuse data together. That's very important. Everyone who works with SQL knows it very, very well. There is a toolbox part. What do you need to know? Excel is certainly important. Python, R, rest is R Studio and the components of R and Python. Python and R are the two programming languages which are core to data science. Python is picking up more and more now because the computational scientists and the engineers are joining the field. Earlier it was R because statisticians' favorite is R. Now, there is something called as visualization also here on the side. If you cannot visualize the information, you cannot make sense out of it. So for me, this is a very important component, that you should be able to make plots and understand those plots. Like you see it in Iron Man, Tony Stark is dragging things around, visualizing everything, because you can make sense out of your visual information much more than what is written. And then there is big data part. Hadoop is there, Cassandra is there. Oracle, I don't see. There is SQL with Pig. So these are just tools, again, to store information and use it for analysis purposes. Now we know that, okay, why one needs to be a data scientist, because the market needs. We know, okay, how to probably become a data scientist. Now the next question comes in, what does a data scientist do? And again, there is a very big misconception in the market that the data scientist always develops, amazing and sophisticated codes that changes the world. Well, maybe yes, but only on the 20% of the time. 80% of the time, one focuses on looking at the data in Excel, using Tableau, making simple plots in Python or R, wherever you feel like. Then you have to explore this data, and exploration involves doing correlations, looking at the distributions of your variables. Okay, what kind of information is present? Then you follow up on that. Then there is why things look like the way they do. You have to ask questions. Okay, is it really the case, what data is telling me, or there is some issue with what I have collected? Maybe there is a bug in some SQL script someone wrote, which has changed the whole data cycle. This is the job of a data scientist to find out. Now there is, after it cleans up the garbage, okay, this really takes around 60% of that 80% time to get the data ready for the next stage of your work, which is the modeling part. This really is the key part, and this is where also a lot of people either pass or fail. So next is that, reference data sets. We all learn about training and testing in machine learning. Oh, we need a training data set, because if we don't have a good training data set, and we cannot test our algorithm, and we will not be able to extend the prediction or inferences to the new data. But where does the training part comes from? That's reference data set. I know of this, this in the artificial intelligence field, the image recognition. Everyone would have heard about this MNIST, MINS data set, which is used for training the neural networks. That's a reference data set. They were actually people sitting and curating that data set. Hey, this is that image, this is that image, this image carries this dog and cat together. So some person did that work in the past, which now the entire community is using. And when you work on a specific data set, you have to create the reference data set most of the time for yourself in companies. So you have to really sit down with pen and paper, okay, what is happening, then put information in Excel or some table. Hey, now I have created a reference data set which I'm very sure about can be used for training. So this is something very important, so one has to pay very special attention to this. Then there is the part about try to understand the problem from different angles. When I think of it, of a problem, I have a limited brain capacity. I mean, unlimited, but still it's limited. So I can only think of a problem from few angles. Sometimes it's useful to talk to your colleagues, or not to colleagues, to random friends you meet. Hey, I'm working on this business problem or any problem. Do you have some input? Let's discuss it. You don't have to explain them what machine learning is and how your algorithm is working. What you have to explain them is the problem. And the people will give you input, and it will help you get your product better. And once you have taken care of all these parts on the top, you come down here. Then you start really writing code. And in that code writing part, I mean, there's also some happening there, but this is the main part where you run the modeling cycle. And if you make mess here, it's going to be all the mess here. So remember that. Now, next is, okay, we know how to become a data scientist. We know that the market needs it. We also know that, okay, what the data scientist does in day-to-day basis. Okay, where do we need it? Where do we need data science? So my perspective is everywhere. If a marketing person would want to sell some suits here, so there is one candidate probably, I just see, who might be ready to buy it. Okay, if there is some jewelry, there are 4 girls in the group, they might be the interesting candidate. So this is the information processing which your brain has to do, or a data scientist has to do, to make sense out of the information. And this is really everywhere. At least for me, I see it everywhere. In the supermarket, apples are one day next to bananas, the day after they are next to oranges, and the next day they change it next to clementine or something. So the supermarket is evolving every day. The reason it's evolving is all because it's data science. People are running algorithms to find out who is buying what and when, so that they can put those things there. Milk goes along with bread for a reason. That all is data science. It has been happening from the past, and it will keep on happening. Now, what I'm going to do is that I'm going to give some examples where I have worked with it, and I'm going to use the examples on which the students in our last data science program worked. First example is fraud detection. So we were approached by an insurtech company in Zurich that they are working with the mobile fraud insurances, and they have like a 5% success rate that they can only identify 5% of the frauds. So their goal was that, hey, can we increase this 5% to around 15%, because that's the number of frauds they expect. So that was one of the projects done with data science by our students. The next one was targeted advertising. This was with a startup in Zurich. They wanted to identify the group of customers, so the segment of customers in their data, so they could do more individualized targeted advertisement. And if you guys know about Alibaba broke the records now on this Sunday Black Friday sale, that they use around 1,000 GPUs to have real-time advertisement on phones. So every person who was online and shopping had a different ad customized according to them. And this was all done by AI in real time. So this is the power of data science and the advertisement per se. Next comes the hotel recommendation system. So we also had a student who was working on data which we received from Expedia, based here, around you guys. And he worked on he said that, okay, building a hotel recommendation system for the person who goes first time online is easy. What I'm going to do is, if a person comes second time online, to increase the chances of booking there. So he approached the problem in a very different angle. He said, hey, look, let's first visit to the website, everyone is taken care of. I want to keep the people who come the second time, because they have explored everywhere and they haven't done any booking. That's why they're back on the website. So he developed a hotel recommendation system. He was invited by Expedia to give a talk, and he was then later on asked to apply for a job. But the guy decided to go for eBay. He said he wanted to be in Zurich and not in the French-speaking part. Later on was a burglary risk estimation. We also worked with the same insurtech company for the fraud detection. Here, the student used publicly available open data from open data source to find out what are the burglary associated features of houses. If a house is old construction, it has higher chances of having a burglary. What locks do they use? What company locks do they use? Where are they located in Zurich? Okay, are they located in the rich quarters? Are they located in the poor quarter, these houses? So all this was learned from the data to come up with a set of features that increase the chances of burglary of a house. And this was a project which was kind of given away by AXA to this insurtech company, and then AXA took the entire analysis, all the results, and they started a promotion called Give Your Data Back. So where people can actually go and type in their address and find out how risky their house is for burglaries. So this is everywhere again. Now the next part is lung cancer diagnostics. We had a student working on working with Hirschladen Clinic in Zurich. It's a private clinic. They have a program going on that they scan people with CT scan for lungs to find out if the lungs have lesions. And depending upon the size and the number of lesions, they try to say, okay, this person is going to develop lung cancer in the future or not. And they had no clue what data they had. They had no idea what kind of lesions are present, how many lesions are present. The doctor was going every time on an individual patient report to look for that information. So this was the exploratory part, and the student, and again another student developed the kind of a diagnostic toolkit for them that doctors could go online, type the patient information, and access the whole thing. Hey, these many lesions there, which is the other patient which is similar to this one? When did the patient start to smoke? What are the chances the patient is going to develop more lesions in the future? At what time frame? So, and then there are, much more projects were done by the students. There was one who worked on the market analysis. We have David here who worked on the churn analysis using IBM data. So there was a lot happening. Now we have covered the introductory part. What I'm going to go do is that I'm going to present how you should approach a data science problem. Forget machine learning, forget AI, forget programming. How would you do it if there were no computers? So this is the way to solve a problem, at least for me. So, how many of you have heard about this CRISP-DM? So a lot of you mentioned about raising their hands. Everyone working in this room is a data science or data analysis. How many of you know this? Cross-industry standard process for data mining. None? Oh, so I think it was good to put it here. So this is a cycle, a data science cycle that was developed using data science. So KD Nuggets, what they did, they sent a survey to the people who are working in industry and are leading data science projects, asking them a bunch of questions, how and what they do to have a data science project start and finish. And finish means deployment, that it's being used. So it's not just done and work is done, the scripts are used, no more needed like in research, they are being deployed. It's nothing more than what probably you do in your day-to-day cycle, but it's really worth keeping it on your desk when you are working on a data science project. Only then you will be able to complete the whole cycle and have a fully functional product ready. So how does it start? It starts with a business understanding. I'm focusing it on business, but it can also be research oriented. So you are approached by someone or you have started to work on a business problem. You forget again the data, there's a business problem. The first thing you start asking question is, what is the problem? Is it a fraud detection case? Is it a lung cancer diagnostic case? Or is it an investment case? Now, you ask the question, you frame the question, and you decide on a detection criteria. Detection criteria is what are you going to see in your signal? For the fraud detection, you want to probably tell a person is a fraud or not. So this is what you want to, you're interested in identifying. Now, you access the situation, you make a project plan, what you want to do and how, and then sketch a plan. Really sketch it with a pen and paper. Then you follow on the data understanding part. Data understanding is what was covered, where the data is present, how is it present, what kind of variables are present, distributions, correlations, are there data quality issues? And you go back and forth between the business and the data part all the time to improve your understanding. And this takes around 20% of your time in a data science project. Now, next comes is the data preparation. That's a 60% of the time, cleaning the data, removing empty rows, removing empty columns, filling in missing values. Okay, now, do you want a single data table at the end or do you want multiple data tables for your analysis? Feature engineering, that comes here. What else can you add? What can you remove? What you should select? What you should not select? And then the final data set is ready for what everyone finds the most interesting, modeling. In modeling, then you start defining, the reference data set. Very, very key to the success. If you have a terrible reference data set, your algorithm is doomed to fail. Then you decide on techniques, regression, SVM, PCA, clustering, ensemble methods, whatever you can find online. or whatever is suited according to your problem. You follow up on that, you describe the model description, parameters, and then assessment criteria. Assessment criteria in case of fraud detection would be, is it a fraud or is it not a fraud? Mean squared errors, ROC curves. These are all your criteria to validate, to see how good your model works. And then there is a revision going on. Some things will work, some things will not work. Those that don't work, they have to be kicked out. Then comes the part of evaluation. You assess every result you have created. You review all your code. You add logging. Logging as in that you write what you have done where. Okay, every step name, the detail of the step, so that if your program breaks down, you are able to go back and trace the changes, which good programmers do that. But I would say that you start using that in your day-to-day life. Only then you will be able to, come to the reach of deployment. And then comes the part with next steps. What are we going to do when everything is ready? So you make a deployment plan. This is usually where the engineers come into play to put the code somewhere on a system which runs automatically without you being involved. Monitoring system and maintenance. When you have deployed something, you have to monitor it. You don't want to just have it running and forget about it. No? We switch off our laptops from time to time for this reason. Then you make final reports, which are obviously given to the board members in the company. And then you review the project and make documentation, which is very, very important. Most of us don't understand the importance of documentation, but we move on from job to job or from role to role. But someone else has to continue that work, so we need to have a documentation. And if you can do all of this by yourself, alone, you are the unicorn. And that's what the market looks for. You should know databases, you should know programming, you should know modeling, preparation, evaluation, everything about the data cycle. But they don't exist. They really don't. So what we do at Propulsion is try to create those unicorns. It's a bit tricky part, but we can try. Now, a bit about Propulsion. We are an educational startup based at Technopark in Zurich. We run 2 programs at the moment, full stack development and data science. I'm managing the data science program. The way data science program stands out from everywhere else is hands-on training. Hands-on training means that we receive data from companies in Zurich who have a business problem associated with data, and the students work on a real business case. They're monitored every week by the company and by the teachers and by me, so that they're on the right track. There is David here, who was also a student, and he moved to Geneva to work with Lukoil, and this is the tools we use, R, Python, nothing usual than what we know about data science. JSON format, pandas, numpy, Jupyter Notebook, Orange. So these are the core techniques we use, tools and techniques. We are ready to open more if people are interested. Now, if I compare what we teach to the roadmap I showed you, which was a really big list, this is what is covered, certainly. The introduction to maths. We take you back to your school time. You receive everything to prepare it before you start the program. Then programming, statistics, machine learning, NLP. We also cover data munging and data ingestion. So what you need to do, so we give you messy data, and then we train you how to improve that messiness of the data. We also cover, visualization, how to make sense out of what you see, or how to see what you are seeing, with the help of visuals. This is what we also do. We cover, ggplot, Shiny, R, Python, Studio. So in the toolbox category, what we certainly don't cover is the big data component. And as far as I know from my experience, most of the companies in Switzerland, medium-sized companies, don't use big data platforms. They rely on SQL or relational databases. Now, so this leads me to the second or the third last slide. Where do the students end up? Because at the end of the program, you want to have a job. So these are all the places. The guy who was working with the hotel recommendation system is at eBay. We have David here, who is at Lukoil. The one who was working on the digital advertisement is in a startup called OneDot. And the student who was working on the burglary case is at Swisscom. This is a financial consulting company in Zurich. And there is more. The next program starts on 15th of January. The deadlines will be closing, I think, the first week of December. So if someone is interested, they can apply, but there will be more programs coming. And this leads me to the best slide. Thanks. So if anyone has questions.
So can you please tell how long does the program typically take, and maybe the structure or something to explain?
So the program takes 3 months, so 1 week less than 3 months. In the first 2 months, you are learning the theory part in the morning for 2 hours, 2.5 hours if I remember correctly, and the rest 6 hours a day you are coding. So you're working, in the beginning you're working on good data sets, clean ones from online sources, and what we're also working on bringing data from companies to train the students also for in-class training. It covers modules from introduction to programming, R, Python, to SQL, how to install SQL, Postgres on your laptop, how to get it running. Then it moves on to statistics, experimental design, machine learning, NLP, visualization, the total 2 months. And every week, every module has 1 week except machine learning, which is 2 weeks.
How many students do you have?
Last time we had 9 students, and everyone has a job, but 1.
How big are the data sets you typically work with?
The current, actually I can tell you what we have called for the next one, 20 GB.
Do you teach how to sell the project, how to present it?
Oh, totally.
How to talk?
Totally. So every day students are made to present whatever they have done the day before. So 2 or 3 students, not the whole class. At the end of at the last day of the week, there is a quiz which students have to present on the following Monday, everyone. And we also prepare them for the interviews, and we ask them questions at least what would be expected in interviews.
Is it possible to do it remotely, or do we have to be based in Zurich?
You have to be based in Zurich. Otherwise, how are we different than Udemy or Coursera? Yes?
What is the cost?
Cost. So if you apply before, like a month and a half before the program, it's 10,500. Otherwise, it's 11,500. Last time we had 2 students who were sponsored from RAF out of 9. So at least in Zurich, RAF knows about us, and they are sending people to attend this program.
RAF is the
The unemployment office.
It's every day?
German.
It's every day for 3 months, 8 to 10 hours a day, plus weekend work, plus weekend learning, and also assignments on weekends. Yes.
I think for federal certificates, you can get some sponsoring from the Swiss Federation.
Yeah.
You don't enter in this program.
Yeah, they take us more of as a competitor, that we are trying to replace ETH, to train people in 3 months, but we say that we are not trying to replace ETH, we are trying to provide more than what ETH does, because we make people work on real systems and real information, and on things where people learn, not just the theoretical part, but the practical side of it. So we had troubles communicating this to them.
Okay. Well,
Perfect.
thank you.
Oops. I guess it's my turn. Just need that. Yeah, actually, I just prepared a few slides because I thought that would be a good idea to prepare. So I would be just actually describing what we'll be doing in the next meetups, and perhaps in the next minutes. So I want to introduce myself and Vince. We are both physicists working at CERN, and actually we are dealing with data, more than 20 gigabytes of data. It's more than that, like
Yeah.
1,000 times than that. In any case, so the idea here is just actually to take some data and analyze them, and in the practical way. So as I mentioned here, so the best way to learn how to do data analysis is to analyze the data. Take some data, analyze it, apply your skills, maybe learn some other skills, and then that's it actually. And you try to extract good information from those data. This is what we do, for example, at CERN. This is what everyone else is doing in data science. You take some raw data, you don't know, you have no idea what is the data telling you, except maybe the context of the data. And then you try to extract some features from it, some useful information, some tendencies, maybe try to make predictions, try to do some classification, and stuff like that. So where to find the data? So there is a nice platform called Kaggle, and in there we can find a lot of data sets and also the purpose of the data set. You can also have some competitions. So you can have a goal of analyzing this data. So for example, we have these sets of images, and your goal is to classify those images as accurate as possible. So you have some metric, and you try to classify those pictures using whatever tool you want and make the best classification that you can achieve. So the idea of the meetup is just to find a problem through Kaggle, and there is plenty, or maybe just a competition and the corresponding data, and then try to explore and understand the data using Python tools. And the idea of Python Meetup is to use the Python tools and try to learn from others and also apply your skills. And I think it's the best idea the best platform to do so. And there is a lot of different tools, as you just mentioned. There is NumPy, pandas, scikit-learn, TensorFlow, and many others. So and then extract some interesting features from the data, try to share with everyone else. And at the end of the meetup is just to present it to everyone else and show your findings. And of course, one of the requirements is to work on group and share ideas, ask for advices, and so on. So, and of course, the meetup has some rules, and the only rule I think we have is just to work only on competitions that doesn't involve money. Otherwise, we will have, if we make a submission at the end of the meetup, we have some problems of, I want my contribution from that submission. So we work only on the old competition. The idea is just to play with the data and work on groups. So this is important because we want to share, we want to know each other, we want to create some community, and of course have fun. And yes, it's not finished actually. So I wanted just to introduce you to Kaggle website. So this is the Kaggle website. So you have a lot of, so you can go here in the competitions, and you have lots of different competitions. So we have already few trading competitions with a lot of money. So if you wanna do some challenge yourself, pick up one of those and do it by your own. But you can come here and learn how to do data science and apply your skills, learn new techniques, how to optimize your machine learning, for example, machine learning, classification, whatever. So for today, we will be just focalizing to do maybe those three tutorials. So I would suggest for the beginners, if there is beginners here, I think there is like 50% of beginners, to start with the machine learning, the Titanic, the famous one, and try to predict who will gonna die actually during this disaster. Or if you are intermediate, you start working with the digital recognizer, which is just, the basic image classification. So you have different numbers, and you try to classify the numbers to the right things, let's say. So, so for the Titanic competition, so the goal is, if we have time, is to make every one of you can make a submission at the end of the meetup. So if you have your laptop, you can start and go directly to this website. So it's kaggle.com. You subscribe. You go here. So to the Titanic, it's in the bottom of the website. you take some data, so they are in here, so you can just download the data, and data look like that. They're quite easy, so you have different columns and everything. So, and the goal is to analyze this data, try to extract some features. So there is already some tutorials on that. So we see, for example, scikit-learn. I don't know if anyone knows scikit-learn here. Okay, very nice. Anyone knows pandas? Okay, yeah, the rule of 50%, very nice. Numpy, and who knows how to code in Python? Okay, very nice. So we're gonna start maybe with that. So if you have a laptop, you can directly go in here and try to understand and go through that. I mean, you can form groups. We can start right now, actually. Just pick up some groups and we can start working directly all together. And the goal is to make a submission by the end of the meetup. You guys, so who is a beginner here? Just okay. If you are a beginner, I would suggest you put yourself on one side. Maybe we can start working together and make a submission at the end of the meetup.
What do you mean by beginner?
Beginner means you don't know how to do data analysis, or you know just a little bit, just enough to download data maybe. And intermediate means that you can work on whatever competition. You can choose a group of a competition to work on. If you want, for example, to do some image classification, so you want to improve your skills on, for example, deep learning and stuff like that, you can work in a group of 3, 4, 5 people and try to share skills about that. So if you are beginners, I would suggest to work all together. I mean, there will be always somebody who knows a little bit about that who can explain. So if there is some beginners, I would suggest to go in this web page here and who knows Jupyter? Who has Jupyter in his computer? Okay, very nice. Who doesn't have Jupyter in his computer? Okay. Maybe we can install it. Yeah, maybe we can start installing Jupyter and Python and sorry? Who knows Anaconda? Okay, very nice. So we can start directly by Anaconda.
It does. Yeah.
Can I start the
Yeah.
So for the guys who knows what Jupyter is and he is close to somebody who doesn't know, maybe you can show him how to install the pandas or use Anaconda to have all the tools for data analysis. That will be quite useful for the next time. But for now, we have just to set up and that's to make sure that everybody has the right setup for the next meetups.
Hi, I'm Christine.
Very good at explaining it. So he turned around and said, this is the steps I went through.
It needs a compiler library, so you can mark some C++ compiler.
Try to offer him a job and just make it work.
Just go here and then mix up like that and start working into
Probably try to presentation first to explain our next mission to the group usually, because then who will use the work.
Yes, I do. I also put some there, so some free. Some sports things, people very much, and it's not something like you're talking in your exactly, if you had to go out and search and scrape it, a lot of it. You have to scrape out things you're allowed to. But most of the time, if it's public data, yes, it's public. So you can scrape it and put it up, and that saves people a lot of time. The program just the time to scrape the data set.